My name is TOH ZHEN YAO from class M1T1. Today I want to discuss and present about the partial questions at chapter 7. First, we need to analyze the question. The question given that a sample of 0.1 g of NaOH, this is base dissolved in 25 ml of water, so this is the volume of the base, and titrated stepwise until 30 ml. That means 30 ml of 0.1 mHCl. That means this is acid volume, and this is the molarity of the acid, and this is the acid user. And then the question asks us to describe the titration process. The question uses the word describe. That means we need to explain the titration process in detail, and the keyword beginning till the end tell us that the question is split into three conditions. This is pH before titration, pH when equivalence point, and pH when end point. And then the part 2 of the question asks us to sketch a graph showing the titration curve. To draft the graph in your mind, that the y-axis is pH and your x-axis is volume of titrant. In this case, the titrant user is HCl. So this is the graph. And the part 3 of the question is if HCl is replaced by a weak monoprotic acid. So there is only one keyword, that is weak. As the previous question gives us, the acid user is strong acid, that is HCl. And now HCl is replaced by a weak acid. After replace, we need to sketch the expected titration curve on the same graph as above. In this question, in the graph there will be the two curves. And why monoprotic is not the keyword? Because the acid user is monoprotic acid. That means this is same with the previous one we used, the original one, HCl. HCl is also the monoprotic acid, so there is no difference. So this is not concluded in the keyword. We just ignore the monoprotic. So let's go into the part 1. Okay. So in part 1, calculation part, we need to calculate the pH of the solution in three conditions: before titration, when equivalence point, and after all the acid is added. From the information given, we know that the mass of NaOH is 0.1, and you put the formula and you will get the mole of the NaOH is 2.5 times 10 power of negative 3. After you know the mole of NaOH, you can find the molarity of NaOH by divide the mole with the volume of water given, that is 0.025 liter. And you will get the molarity for NaOH is 0.1. The volume of acid given is 30 ml, and the molarity also given 0.1 molarity, and the mole of HCl you can calculate by the formula and find out the mole of HCl is 3 times 10 power of negative 3 mole HCl. So the first step is calculate the pH of solution before titration. Before you calculate, you need to know that what substance is titrant and what substance is analyte. In this case, we know that the titrant is HCl acid and the analyte is NaOH, that is base. You need to find out the pH of the solution, so that means you need to find out the pH of the NaOH. NaOH concentration is equal to the hydroxide ion concentration. The hydroxide ion concentration is 0.1 molarity, and we put the formula of POH and we get the POH equal to 1. After we know the POH, we put the formula pH plus POH equal to 14, and the pH finally is 13. When the equivalent point, what's the pH of the solution? Actually, we no need to draw the ice table. Put the formula MAVA divided by MBVB equal to A divided by B. So from this formula, you know that the volume of acid used to neutralize completely the base is 25. In this case, type of titration is strong base and strong acid titration. The concentration of hydrogen ion and the hydroxide ion is the same. At equivalent point for strong acid and strong base titration, the pH value is equal to 7. So the step 3 is we added all the HCl into the solution. So what is the pH of the solution? You need to use the ice table, and first step of the ice table, you need to show the equation of the reaction. And after you show, you need to put the value of the mole of solution. Mole of NaOH is 2.5 times 10 power negative 3, and the mole of HCl is 3.0 times 10 power negative 3. And we minus the 2.5 times 10 power negative 3 in both. Why minus 2.5 times 10 power negative 3? Because the value is smaller, and the mole of NaOH left is 0, and the HCl mole left is 0.5 times 10 power negative 3. After this, we can find out the concentration of hydrogen ion left by using the mole divided by the final volume, 25 plus 30, 55 ml, and convert into liter, 0.055 liter. And final, the concentration of hydrogen ion is 9.0909 times 10 power negative 3 molarity. And we put the formula pH equal to negative log concentration of hydrogen ion, and we know that the pH of the solution in step 3 is 2.04. So the calculation part is divided into 3, and each part got 1 mark that you can score. And now we go to the next part of the question, that is the explanation part. You need to describe the titration process. To describe the titration process in detail, you need to put all the information given into your sentences. So in the beginning, the NaOH solution that is diluted in 25 ml of water, and the solution has 13 pH, which is basic. And when the acid HCl start added into the solution, pH of solution start to drop because the concentration of hydroxide ion decrease. This is the equation for acid and base reaction. So the hydroxide ion react with the hydrogen ion from acid to form the water that's neutral, and the equivalence point is achieved when 25 ml of HCl is added into the solution. And we know that at the equivalence point, the pH is 7, and this because the hydrogen ions completely neutralize the hydroxide ions in the solution, and the concentration of hydroxide ion and hydrogen ion are in equilibrium. After this, when the HCl solution is continuously added into the solution, the pH of the solution will decrease. And finally, the 30 ml of HCl is added into 25 ml of NaOH, and we get the pH of the solution is 2.04, that is acid. So there is 5 marks in the explanation part. So and now we are going to the next part, drawing graph. This part, you can aim for 4 or 3 marks. So where is the 3 mark from? First mark from the y-axis, and other mark from the x-axis, and the last part is from the shape of the curve. We can see that the titration is start from upper part. Because the analyte is basic, so we start from the basic part. So at the starting point, the pH value of NaOH is 13, and after you added the HCl acid, the pH will start to drop and become straight line when near to the value 7. And after the value of 7, the acid is continuously added and causes the solution become acidic. And we know that the equilibrium point is occur when the acid added is in 25. So we need to draw a line up to the equilibrium point and label 25. So now we go into the next part. This is the last part of the question. The HCl is replaced by a weak acid HY. So how we can know the difference between weak acid and strong acid? First, the definition of weak acid is the acid that produces low concentration of hydrogen ion when dissolved in water. So the lower concentration of hydrogen ion produced by the weak acid will only form the solution has a higher pH value. That's why the curve of the weak acid will be shorter than the strong acid. In this last part, the marks given is only 1, and that's all for my presentation. Thank you.
That's all for this video. Please do remember, subscribe, like, and share. If you have any question, please don't hesitate to consult with your lecturers. Stay at home, stay safe. Bye.